it's a lightning talk. Don't try to explain everything. You don't have to introduce yourself. So you can just start what is your selected database, what is the main characteristic, what you can do using your selected database. So that is the purpose of the today's presentation. So most of the time I will cut your presentation. That doesn't mean your presentation is horrible. So because due to the time constraint, I'm going to cut. Or sometimes I'm going to ask a very simple question, so you can just answer very quickly, but a short answer. You don't have to try to defend your the idea. Okay. So first the Saigon. Saigon not here today. And Menes. Menes number 2. Menes not here. Hinduza, not here. Joseph, Michael Joseph, not here. Okay, so you will be the first one to present today. Okay, so I will give the extra point to those who marked it today. And then so on. Parma, Manisha, Navina Meka. Okay, so you are the second presenter today. And Divya, okay, you are the third one. And Shreya,
yes, sir.
okay, you are the first one. Jagriti,
Yes.
you are fifth. And Ashik Kumar Patel, here Venkata, DJ the Rayudu, here the Vidhar, okay, so sixth. And then the Gida, you are the seventh. And the Shiva Cheha, and here, Udaya, okay, eighth, and Balu,
Yes.
okay, you are the ninth, and Ravana, okay, so you are the 10th one, then the other will be back to the beginning, then we will continue. So, first presenter is the Michael Joseph.
The PowerPoint format is in your mailbox. Can you download it?
It's already here, so I don't want to waste the time, so I'm going to use your uploaded presentation file for today. Okay, so then the next presenter be ready in the front. The next presenter is the Navina.
Okay, my name is Joseph, and I'm going to present for a company that designed a database system called NOS or NOSDB. NOSDB is a NoSQL database, or not only SQL database. It was developed by a company called Alakisha. And it's a JSON-based document. It supports traditional SQL statement and as well as MapReduce. The operating environment for the database is on the server side. It's being hosted by Windows 2000 servers, Windows servers, and it's set up as a cluster of Windows, and each cluster has what they call partitions, and each partitions have or shards. Each partition has a primary node and one or more nodes that are gonna serve as not really backup, but they call them.
So this is basically to support the big data.
Yes.
Okay. And what is the basic data type that they can support?
JSON.
JSON is a document database. Then why name is the ObjectDB?
It's not ObjectDB.
It's a NoSDB. Why is it called a NoSDB?
They didn't provide an explication for the name. It's probably just in
Okay. So it's for the document database. For
yes,
the
it's a document database.
But there's a very large JSON file. So looks like
I was on the client side. The client can be either Unix or a Linux-based system or Windows, because they support both APIs for .NET and Java, and you can manage it using the company's own program called NOSDB Management Studio, or you can use Microsoft PowerShell, or you can use Microsoft Visual Studio. So the architecture of the network architecture it's a distributed network horizontally. It's made of, as I said, a bunch of shards, and each shard has the primaries and replicas. The write requests are sent only to the primaries, while the read requests are sent to all the nodes, primaries and replicas. And read and writes are done in parallel and all the servers that the data is located.
Do you support any the indexing technique?
Yes, they do.
Okay.
They even support primary keys.
Who is the manufacturer?
Alakidosh.
Is it famous one? I never heard about that.
Yes, they are famous for a database called Encache.
Okay.
In fact, all the technology that they develop in Encache is also integrated into Windows.
Also, do they support the API?
Yes, the API and Java API. So the client can be either Windows or Linux based.
Okay, very nice. Thank you. That's it. So next, why don't you close? If you are done, why don't you close your presentation file, then it will be easier for the next person. Yes, close. Close all. In your case, you can close all. Yes. So next one is the Navina, Mecca, the Orange TV. And next one is the Divya. You are the next one. Your file is already open. Well, double click yours. Why don't you slide the show? Are you right? Yes. Yes, right?
So OrientDB is the open source NoSQL database management system. It is a multi-model management system, and it is written in Java, and so it is platform independent. And it supports schemaless, schemaful, and mixed mode schemas. And it supports SQL query language.
So support the SQL means do they support the SQL standard or the SQL style?
SQL style.
Okay.
And it supports all the ACID properties.
So they have the consistency,
Yes.
like the relational database. So, okay.
And the features of OrientDB are, it is easy installation. Since it is open source, it is easily available. The community edition is available in the website. And for the installation, it requires JDK 1.7 or above.
So fully Java based.
Yes, it is Java. And it is platform independent as it is written in Java. And
What is the main data type they support? What kind of data type?
support integer.
Integer, I mean whether that is document
Oh,
or
it is a multi-model.
Multi-model? Oh, okay.
And coming to the speed, OrientDB processes around approximately 20,000 records per second. And an independent study by IBM shows that OrientDB is 10 times faster than Neo4j. And it is very easy to use, and there is no cost involved in it, and it provides security. And it supports all the four models, document model, graph, key-value, and object model.
It's interesting, they support the ACID also. Okay, so what about the API? So do they support only Java API or only Java? So you should implement it based on Java. That is kind of a limitation also, right? So, and is it commercial product or there is for the just the education?
We can use it for both. There is
I mean in the market, is it the commercialized one?
yes.
Oh, okay. Okay, good. The next, the Divya, why don't you close your file? Yes. So it's a foundation DB, not multi-model DB. It's a foundation DB. Okay.
It is also like multi-modal.
Okay. Yeah, because it's my mistake. Go ahead.
Foundation DB is an open source database. It was actually it was released in a public.
Oh, why don't you slide the show? Yes.
So this was first released as a public beta release. It was not taken by any of the company. It was released publicly, so that.
So Apache Foundation, the project. Oh, okay.
Yeah.
So it's a fully open source.
Yeah, fully open source. Later, Apple has taken up this and it has improved it and has released it first.
So which means Apple use.
Apple is the main thing
Oh,
that
okay.
has developed the TV. Foundation DB, it fully supports the asset properties. So here, Foundation DB gives the users the freedom to select its data structure, like the storage services. It also supports, it has few API references which can take Python, Java, Go, which is a new new language that is set up by Google. It also gives API references for that. So you can write, like you can create any database using, like you can take all the data types. You can use attributes like ER models, tables, arrays, everything. It can be stored and worked on it using Foundation DB. Later, when coming to the CAP theorem, basically as it is an acid, as it supports acid model, it sacrifices availability over consistency, but in real world situations, because of its fault tolerance thing, it even works when all the systems fail. So I will first show you the fault tolerance system. Here what it does in Foundation DB, it stores the data in multiple places. So the same set of data is available in the form of partition. So in the diagram, if you can see, if the partition A fails, the same copy is stored to other two partitions. So other clients who are using them, they can access the data, but the clients who are using A will not receive for some time. That fault can be covered by DLC.
Yeah, it looks like the Foundation DB it supports the many different models,
Yes.
right? In your project, in the second page, so what are you thinking about for the specific data type? What kind of data type are you thinking?
Like I would work on like databases.
Yeah, so it supports the graph, it supports the key value, it supports the document. So what specific data type are you thinking to implement your Foundation DB? Key value? Any data set do you find? None yet?
Not yet.
Okay. Okay, thank you. Very good. Next, the Shreya. So hypertext. And the next one, the Jagiriti will be the fifth one. It's the hypertext, right?
Yes.
Hypertext, it is one of key value and document store database, and here mostly like the database hypertext, it enables system to achieve strong
What's the meaning of
consistency.
the next generation of key value?
Like this is the next generation, they would say, because in order to overcome problems, like the previously we have NoSQL databases, which hypertext stands out because it solves the problem for search problem, fault tolerance, and consistency problems. Like for example, in consistency problems, some of the database reads, if a user wants to access, it will read inconsistent data, so they would say hypertext overpowers it, so it's called the next generation database. Yeah. And then here, hypertext is one of the richest application program interfaces, where it supports bindings for C, C++, Python, and NS Node.js, and also Python. And the main concept for hypertext, it would be hyperspace hashing, and it also supports asset transactions and value-dependent chaining.
So it also supports the ACID.
Yeah, asset transactions too. And one of the motivations, like I mentioned previously, hypertext overpowers the problems which the other NoSQL databases face. Here in search problem, without a key value, it would be difficult in order to search a value. And then fault tolerance, most of the other NoSQL databases have low latency, low threshold for fault tolerance, whereas hypertext overpowers it. And the next one would be characteristics. Here characteristics, we have performance, consistency, fault tolerance, scalability, and is a very user-friendly interface. And when it comes to consistency, hypertext, it allows strong read and writes. So it will be, it's guaranteed with, it also supports safety operations when we do the consistent read and writes. And And the next one would be, yeah, the data model. Here in the hypertext data model, we would use key value in order, every key is taken as an object. So we would retrieve it when it matches the table value. So I'm going to take key value here for the data type. And it's an open source, and it can here it can also be implemented using hash maps and hyperspace mapping. Sorry. Okay, and the brief manual installation, you could
It's okay for the manual.
okay, and the data definition and data manipulation. Here, firstly, you have to import it the client or the
It's an
user.
example of a Python.
Yes. Here, in order to create an object, here you use c.put in order to create an object, and then in order to retrieve it, you can use c.get in order to retrieve that value.
Okay, that's it. The next, the CDAR, the layout, the database, CDAR, Selbum, CDAR, no, so it's the Allegro, Clarity. Okay, go ahead. So the next one is the CDAR, Selbum, layout, the database. Why don't you start the slide to show? Next one, yes.
Okay, my database is Allegro Graph. Basically, it's a closed source triple store, which means in this data is stored as RDF. I'll tell you what RDF is exactly. It has high performance because it automatically scales. Because in most of the databases, you'll have a fixed memory, and most of the memory will be not utilized. So here it has automatic scaling. And it was developed by France Inc. and was made available by the end of 2004. It works with Python, Java, C#, Perl, Ruby, Common Lisp, and Clojure. I don't have a lot of idea about Lisp and Clojure. It is available on Mac OS, Linux, and Windows operating system. Motivations to choose this particular database is, it is a closed source store. Even though it is a closed source store, it's been used by most of the open source projects these days, defense projects and commercial projects. In this social network, since it's a graph-based database, it's easy to integrate values and all that. So social network analysis is being used, they use Allegro Graph. And for most of the applications, graph-based databases can be faster, flexible, and more understandable. Okay, characteristics. Since it is in the form of graphs, whatever output you get is easy to understand. And because of this, it's used for data retrieval, data analysis, and reasoning. Now coming back to what is RDF. RDF stands for Resource Description Framework. In this RDF format, each of the data is stored as assertion. That is, assertion can be split into subject, predicate. Like, you know how a sentence is, right? So whenever it reads the data, it is split into these particular aspects. So then it's taken and analyzed and interpreted in the form of graphs. The logical structure of Allegro Graph consists of assertion, indices, strings, free text indices, and deleted records. So you don't have to process the data, and more of the processing is done by Allegro Graph itself. Brief manual about it. In order to use Allegro Graph, basically you have to download a server, and these server can be downloaded by two methods. I have put up the links for these. It has a easy to read manual in my paper. So the two methods are from RPM and from tar.gx, that's the zip file. And once the server is downloaded, you can connect it to the you can connect to the server and start querying. It is easy as SQL querying. And
okay, that's it. Thank you. So next, CDAR, Selbum, and the next, Guido.
So the database which I have chosen is React.js. It's basically developed by Bashford Technologies. They have three kinds of NoSQL database developed. One is React KV, which is key value based, and the other one is React
So is
TS.
there any other version of the React, like the React KV, React TS?
Yeah,
So it's a different.
Yeah, yeah.
Oh, okay.
So the basically three of them. React KV is the basic model, and React TS is developed on top of React KV, which is specific for time series and IoT application. And the other one is React CS, which is for cloud storage. And why time series is important, as we all know, data is very critical nowadays, and any data which is associated with health sector or economical sector or even financial sector needs the
Can you give us
timestamp.
the example of such a time series data? Like what kind of time series data?
Like
For example,
hospital details or any
Hospital?
bank transactions,
Bank
anything which has the economical value or financial
does it
details.
require kind of sequence of data?
Yeah,
Like for
yeah,
example, we have the sequence of data, like the sensor, periodically generate the data.
Yeah.
But the hospital data, it has a timestamp, but it's not periodically generate the data. What kind of data does the React TS support?
it supports regular interval-based data.
Interval-based,
Yeah.
okay.
So those kind of data is very critical, and hence that's the reason for choosing one of the TS-based data. And compared to all other NoSQL database, this React TS requires huge amount of workload done with the read and write operations being performed. And why React TS? As I said, it has a masterclass architecture wherein 3x architecture is being followed. So any
Do
data
they
which
support
is
any streaming data?
no.
Because it's like the most of the time series data generate the streaming. So like every time it's almost real time. So I'm not sure that this database can support the incoming the streaming data.
No, streaming data as far as I know. And the 3x architecture is wherein it is available in three availability zones. So we need not worry based on one location. Even if the data is lost at one location, the other two locations are always available in order to give consistent data availability.
What kind of API do they support?
They support SQL based API, and it supports multiple platforms like Java, C++, Python.
Okay. Okay, thank you. Next, the Gita. Why don't you close your, if you are done, so why don't you close, that will be helpful for the next student. Going to the Explorer, then select the year.
Okay, I searched for Azure Cosmos like document to start logical database. So it came out like because of its easiness, like with a click of a button, people can easily scale up the storage and throughput. So it has a powerful advantages like that provide latency, availability, throughput, and consistency guarantees. Instead, Azure Cosmos database has a strong characteristics such that it supports not only document style and also has approaches such as column families and graphs and like any other styles of the database. And then Azure Cosmos database provides very wide load latency and then availability and predictable throughput and multiple well-defined consistency models. Azure Cosmos database is Microsoft globally distributed and multi-model database.
Basically, what can we do using the Azure the Cosmos database?
It supports like many APIs.
So what kind, for what? The API is the interface for applications. So to do what? So what I can do using the Azure database.
It basically puts some database,
So what kind of data?
JSON.
JSON file is
Yeah,
basically the
that's it.
document database. Any specific purpose of the Cosmos database, like this for data analytics, or this is for the management, or any specific purpose?
Actually, it only mostly for big data.
Big data.
Yes.
So any specific data type does the Azure support?
It supports many types of data, like document, key value, the graph, and column value.
So it's about the multi-model.
Yes.
Okay. And what is the benefit comparing to the others using the Cosmos database?
I didn't search for the.
Okay. Okay, thank you. Next, the Udaya. It's a React but different from the React TS. Udaya 3 ready? Yes. And the next, the student is the Value.
The database which I have chosen is React NoSQL database. React is an open source database which was developed by Basho Technologies, and the database is written in Erlang language, and Erlang is also prerequisite for installing the NoSQL database.
I heard about the Erlang languages. So any the characteristic of the Erlang language? What is the Erlang language?
It's similar to
Ever used? No. So then
it's
the
similar to C, but it supports it is a lot simpler than
simpler than the C, but it's very high level, or the like the C is a low level the program language, or it's a script, or just a procedural language.
it is possible.
Procedural language. So which means we need the compiler for the.
The prerequisite we also need GCC Turbo C compiler for this.
Anyone who ever used the Erlang? Yeah, I recently heard a lot about that. No one? Okay, so go ahead.
And the main feature of the React NoSQL database is its fault tolerancy. And React is providing 3 versions. The React KV is an enterprise version.
So KB looks like a key value. What is a CS?
Cloud storage.
Cloud storage. What is the main purpose of the CS?
CS is mainly used for the cloud applications.
Cloud application. So it's a kind of a general purpose the database, but it's in the cloud.
Yeah, it's in the cloud.
And TS is the
TS
previous
is
student
science.
presented. Go ahead.
And the main influence of developing React databases is the CAP theorem and Amazon's Dynamo paper, as the Amazon Dynamo paper is the paper where NoSQL database have been introduced first.
So it's a bit similar as the Dynamo.
It is influenced from it.
Okay.
And it is also previously the users, the architects who have developed Akamai have formed group together and developed this React database. It is a key value database. It uses keys and keys to store the values in pointer store. It is a masterless clustering.
So are you thinking any specific data type in the second page? I mean the page 3 and 4. Are you thinking about the specific data type?
Specific data.
Yes, because you have the React KS, React CS, and React TS.
Yeah,
So-
I would like to work on React CS.
Yes. Okay. That is the key value.
Yeah, key value. And React supports its own data types, like it has registers, counts, sets, and flags has its own data types. And the operations are pretty simple as a relational database SQL, which are nothing but get, put, and delete. And then the main features of the React is its fault tolerancy, and it supports all 3 features from the asset properties, which are nothing but consistency, isolation, and durability. And the main reason for fault tolerancy is because it uses multi-cluster replication. Multi-cluster replication isn't when the data is given to the database, it duplicates the data over 3 servers. So that even if one server fails, we can access the information from other 2 servers. And it uses links in the object, and this is the format for the links.
reproduce the
Yeah, we
using
can
this one.
reproduce that.
Okay,
And-
thank you. The next, the cloud, the Firestore by the value.
Hi, I'm talking about CrowdStore. This is developed by Google. Usually people, whenever they want to develop an
So on the GCP or the just Google product?
it's a Google product.
So it's not on the GCP?
It is not on
Okay.
GCP. So whenever people develop application, they want their data to be in cloud. Due to many reasons like hardware, security, all these things, we have to manually manage it. So Google has come up with this. It's a Google NoSQL database. In the motivation behind this was Firebase in 2011, they created a chat service that's like a real-time database. Google, inspired by that, they acquired this in 2014 and they released as Firestore in 2017. There are many, it supports, the characteristics are, it has been used by all the Androids and iOS devices for notifications currently. And the characteristics is you can use this along with other Google features like Firestore authentication, real-time syncing with online or offline databases. It also supports Crashlytics. That's if your application or if there is any crashes, it generates those kind of reports and gives you real-time. And the analytics is absolutely free. So it supports a database model, a document model. The format is in JSON format. It has a collection. A collection is a group of documents. And again, it has hierarchical levels like nested documents and having sub-collections, etc. So the supported languages are, there is a couple of mobile and programming languages it supports. Along with that, it supports even the REST APIs also. So you need not worry about which programming language that you are using. So supported data types are arrays, booleans, etc., maps. Creating a project is very simple. You'll have to just log into console.firebase.google.com. Just create a project. This is sample data which shows the key value pairs in a document format. To include this, all you have to do is in Java, you'll have to just include Google Cloud Firestore jar in your program, and you'll be able to, using one command, you can create a document, and using one line, you can delete or modify any records. So the main conclusion is.
Okay, thank you. Next, the Bhavana for the Memcache database.
So I have chosen the Memcache as a NoSQL databases. As we know that NoSQL databases process huge data and it supports a different different sort of data like document graph and key value pair. So Memcache is one of the databases which is widely used general for the processing of the data which we get it from like Facebook, YouTube, and which generates a really huge dynamic web pages. So basically it supports, like it uses the data type of a document, graphs, CSV, XML format, and it uses, for the processing of the data, it uses a key value pair. So in order to create a key value pair, we can decide, like for the document, we want a different kind of a key value pair in certificate, so we can manipulate that thing in this database. So this Memcache database is basically solely based on the caching technique which we use in the CPU. So in that case, whenever any site is getting loaded at the web server side, so it is directly hitting to the Memcache database server, and from there it requests for the user. So Memcache database always holds some of the information or the frequently accessed information from the user or
if it's any of the time data is not present from the database, then it returns to the client directly from the database. Also apart from that, it serves the basic purpose of like client server architecture. So there are the cluster of web servers and web caches being present, and like depend on the different regions, locations, or the countries, they are trying to access the data from the.
So their main data structure, the storage are in the memory.
Yes, no, it's a different database.
Different database.
So this different database has been completely associated with the web server. So whenever the web server is getting installed, we can connect it to the Memcache database using that.
So where do we install the Memcache database?
Yes, we store it using we create a connectivity between the web server and Memcache. So there are the certain commands which create.
So my question is, where is the what is the main storage of the Memcache database? Because the name looks like the memory cache.
Yes.
So I wonder whether they use data structure on the memory, or the memory is just a cache and their main storage is on the file system.
No, that database itself is a cache because it's
Cache.
extremely.
So it's basically cache.
Yeah, that's why it's extremely fast. So whenever the web server is getting connected, it keeps all data readily available for.
So how do they overcome the limitation of the memory structure?
So they have their own memory structure. They have designed it. That entire memory structure has been elaborated in the Live Journal when it was published in 2003.
Yeah, so they have the kind of durability, which means what if the power is out, do they lose the data? Or
So that's why they have the different cluster of Memcache also. So any of the database is down from the Memcache database server, they can switch it to another database.
So always they have the
load balancing thing is available with them. And also it provides the consistency because the Memcache, whenever any of the database is been updated in the main database system, so they have the frequency has been set, say after 10 minutes or 20 minutes, they do refresh this Memcache. As well as any updation deletion has been.
So do you think that you can implement this one for the second phase, the phase 3 and 4 after this?
Yes, I am planning to create one website using the PHP, and I have already tried to install on my GCP the Memcache. So I tried
So you can use the virtual machine, or you
Yes.
can run the several virtual machine and run
Exactly.
that makes sense. Okay.
So that's why I can be able to achieve it. So there are different APIs has been available, so we can
Can you
access.
use the app application, what is that, the Google, the app engine for that web server?
Yes, I have installed in the GCP itself the Memcache. So there are the certain commands we just have to use that to get it installed and get it connected. So that the different APIs has been available. It's like a key and value pair of a database, so that get keys and set keys, these are the basic APIs has been available. Apart from that, it supports for the Java, Python, C++. So
basically this the database used for the efficiency of the app web server.
Yes, that's why it is associated with the websites.
So they pretty much they keep the the document or the JSON file as the data.
Yes, but I have read that we can use it with the other normal databases, relational databases also, wherever the response is more important for the user.
Okay, thank you. So we have the 10th presentation. So far those students who are on time will get a little bit extra point. We're going back to the first one. So then the other 9 students will present. The first one is the Sairam. For those who are late, we are going to have the very short presentation within 3 minutes. So it's a lightning talk, so you don't have to introduce yourself. So you can just present the main part of your selected database. Even though I cut in the middle of your presentation, that doesn't mean that you are horrible. Okay, due to the time constraint, I will cut or start your presentation. Okay, go ahead.
This is the object database, which is in general taken from object-oriented database management system. We choose objects which are in general used in Java. It is completely done in Java. It is a commercial database and it can be used, it it has a free access to small databases such as for 10 classes and 1 million objects. And it also operates in two modes, embedded and client server mode. Where in embedded mode, it only has like one application at a time. And also when it comes to client server mode, the client is having the access to the application, and also the different tools for this is like BERT, TryBERT, Doctor, Explorer and Enhancer, where Doctor is like whenever there is like any corrupted file or something which is causing crash, is available. It has a it will identify the thing which crashes, and it will take out the thing which is restored, and it will start a fresh database. And these are the features of the object database. Firstly, the capabilities and scalability. Like object database is like really, it can be used from kilobytes to very terabytes. It has a maximum capacity of 128 terabyte, and it has access to its Java API, Java Persistence API, and Java data objects. And also, it is really high performance. Like the performance and the speed of the object database is high when compared to the other databases which are having the support of APIs. And the primary key supports is also there for this. And this is having a Java persistent query language.
So this is the object-oriented database.
Yes.
Okay. Then can you give us the example of the sample data that can be stored or managed in your object database? What kind of the data? Is any kind of data, like the relational database, but they use different data model. So what is the idea of the object DB?
Object DB is like it need to have a support of Java. It need to have support of Java persistent like API, which is an interface between two models. Like it may be two web servers or maybe something like that. But it can only take up to the some limit, not like the very big databases. It only like a small.
It also supports the big data. Okay, thank you. Next, the Mansi regarding to the Alamguru DB. Mansi, the Alamguru DB. Why don't you close with this one? Thank you. And open here.
Good evening, everyone. My topic is AlgoDB. It is a distributed database. It is a multimodal database which comprises of document style, graph style, as well as key value. So I have an option of using either of the three, or the combination of the three. It is non-layered approach. Sorry for the mistake there. Because I can use any of the three model databases, so it is a flexible database. Single core, single query language means that I can use the combination of all the three databases and query it, and in a single query I can execute the database. It uses AQL language, which is quite similar to SQL. These are the properties that I can say which will help me to choose the database, to choose the data model. Cluster is nothing but key value. So if I'm using a key value database, it will be multi-master, so it will be a master-slave combination. It will horizontally scale. Automatic failovers are handled in this. Because it is automatically handling the failover, so self-healing process and architecture it follows. Synchronous replication is there, which will be using a replication factor with the help of which the synchronous replication can be made. Graph data model can be used when there is a pattern matching in my data set. Document style is used when there is a complex query like joins and all. It also handles JSON objects. And indexes can be used if it is a document-based data model. The characteristics of this database is the synchronous replication can be done automatically, so it handles the failure as well. it self-organizes it due to which the failures are handled by itself. Is it easy to maintain? No switching between the data models is nothing but I can use either of them or the combination, but I cannot switch from one to another. ACID property is followed in this data model. The AQL, that is AringoDB query language, it completely resembles SQL, just the few syntaxes differs. It supports reading and modification of the data and also is used to delete, manipulate and do the other filtering of the documents. This is these are the names
Is
that
that very
can
similar as the
SQL, yes, yes. Only the syntax, you can see the queries is also mentioned here. The insert query and all, it is quite similar except the syntax, it changes a little. This is the example of AQL.
And what kind of programming interface do they support?
It also provides RnWash, which is a shell which is provided in JavaScript, and where I can use my AQL language and do the query.
Okay. Okay, thank you. So next, Hinduza, the Voldemort TV. Hinduza? Yeah.
Good evening, everybody. My database name is Voldemort. As you know, it is named after the Harry Potter villain Voldemort. It's a post-distributed database. Here, the data is stored as a key-value pair. So, more than that, it also stores the complex data type like list and map. Each cell is not restricted to integer or a character or something. It can even store list which can hold multiple values. That is the main advantage in this database. It's linearly scalable. Means like you can add many machines or DB at any point of time and it can scale automatically. Then it supports AP in the CAP theorem, nothing but availability and the partition tolerance. The motivation is like here, relational database, before it processes actually in the cache, it stores as a key value pair. Before processing whatever the data we have in the relational database, it stores in a key value pair. But here in Voldemort DB, the data is itself stored as a key value pair. So obviously it will be faster than the relational database model. Then the data storage is persistent. Here, Voldemort uses actually ring algorithm. Ring algorithm means all the servers are arranged in the form of ring. So when it's storing a value or when it's retrieving a value, it uses hashing. That's what we are here named as consistent hashing. Hashing will help you to select the data more accurately than any other database does. Here, if you remove a server also, the hashing can be, like the algorithm that we use for the hashing can be changed and we can take the data immediately. For the normal databases, if you are removing a server, we have to reconstruct the index and everything again and change the values there. But here, you have to just change the hashing value. In that case, the data can be picked up more accurately than any other database. The characteristics, it supports automatic replication and partitioning. It also handles all the server failures very transparently. Since the database is distributed, obviously we don't have any single point of failure. Here, it supports serialization. The architecture is actually a layered architecture. Here, though it's layered, we can mix match the layers to support our own type of requirement. For example, if you want the routing should be to be done on the client side, you can make the routing in the client side. If you want the routing to be done in the server side, you can do that. Though it is layered, we can mix and match it. There are two types, like, sorry for that, two-tier and three-tier. In two-tier, we have a front-end routing. Means like the application, wherever the application is there, the application will route to the correct server. The routing is not done in the client or the server end. In the three-tier, there are two options. The routing can be done either in the client side or on the server side. This is the brief manual of the installation.
I think it's okay.
Yeah.
Okay, yeah, that's done. The next, the second, the lead in the database. No, it's a different topic or the something additional information. Please use it. It will take a time to download. Do you have the file right now? Why don't you plug in the Varma, and followed by Manisha. Okay, start.
I use the Rethink database.
I can choose slide to show. Bottom right. Yes.
This Rethink is open source database optimized for real times. It has Rethink is open source database optimized for real time. It support for joins and bridge parties for reql and charge feeds.
So what's the meaning of the real time here? Is fast or what? What's
It's
the meaning?
updated, it's real time.
Updated
Yeah,
real
updated
time.
data. Yeah.
Mhm.
And it has powerful advantage of real time. And it Rethink's platform is Linux OS and Windows, and data model as JSON documents, and data access and unified changeable dynamic query language, and yeah.
What's the meaning of a unified, changeable, dynamic query language? Can you explain? Yeah, because it's like something other characteristic.
Yeah.
Unified, maybe, okay, you just combining several query, then it can make the dynamically change the query by accessing the different data source with a different query for the one. Looks like the,
Yeah, like mixing the query with JavaScript, expanding
Right.
languages. And the data model is regular data types and data and times in binary object and geospatial queries. And this is good for collaborate web and mobile applications, and because this is real-time project, so it's real-time marketplace and connecting device and multiplayer games and streaming analytic applications. And the language of the Rethink database is Java and JavaScript and Python will be C#.
why you should put the title as analyzing picture in Instagram. So you put the title of your writing of as geometrically analyzing pictures in Instagram. So are you going to use such a Instagram data set?
I thought that like I have to preview something like which project I'm going to develop something. So I just put some
So
specific project in here.
So reading database can support the geographic
Yeah,
data.
yeah. Geographic data. So I get some data from the Insta using the Instagram API.
Okay.
Then I collect the data and I will show the visually in the geographically.
Okay.
Yeah, I set that kind of project in there. So I surveyed about that, but I didn't know that like I have to explain about the Rethink database.
Okay.
Yeah. So I changed it.
Yeah. Okay, thank you. The next, the Varma. How do I call this database name? How do I pronounce? Scylla. Okay, the Scylla database.
So the database name is Scylla. The company's name is also Scylla.
Any meaning of Scylla?
I didn't have the time.
Okay.
So what is Scylla? It's just like another NoSQL database, and the only difference it's more like comparison between Scylla and Cassandra. So already by 2009 Cassandra started and it's market leader, but the guys behind this Scylla they have hypervisors. So most of the time they work on kernels and C++. And they saw Cassandra. Cassandra is good, everything is going good, but they saw a drawback in Cassandra. The drawback was Cassandra most of the time we did in Java. So they saw this JVM. So everyone knows, when we use JVM, we go for threading and all those things. So they saw a scope. They have a scope for improvement. So we're going to discuss about that improvement and what they do there.
So it's kind of
it's more like
Cassandra, but to support the
yeah,
Java-based application.
Yeah, it's more like another next version of the Cassandra, improvement on Cassandra. So
what
these are the
performances?
these are the statistics. You can see a large difference. So the violet are the Scillas and these are the Cassandras. So we'll see why why such a difference is there. And this performance wise, there's a 10 times reduction cost. And how is this possible? So these guys, as I told you, most of the time they worked on kernels using C++. So they are good in C++. So they did everything in C++. But that's not the only thing. C++ is not the reason why Scilla is good. There are other reasons too. So shared nothing approach. So when you go for threadings, so what happens is there is this centralized resource where all the threads wants to access the centralized resource. But that's not what happens in Scilla. What they want to do is, as we have more cheaper resources, why don't we give more and more nodes? But for each node we'll have only one thread, so that each and every thread doesn't compete for one resource. Each thread will have only few. If there is 100 MB of data, each node will have 10 MB distributed, and each thread will work only on 10 MB of the data on a single node. They won't compete each other with for the resource, and they won't interrupt in other tasks. Let's mind our own task and we'll do our own task. So what happens in edge case scenarios? Probably you get one request in one node, but the thing is the data is present in other node. So in that case, what they're going to do? So what they're going to do is, instead of going for this thread approach, so we have this thing called future and promise. So what they're going to do is, let me give a request to another node which has my data, so that I'll let the node perform the task and just give me my response back. So what this node does is, when it sends the request to another node, it gives a promise to me. So don't worry, I'm going to give a response to you, just wait. So when the other node finishes its task, it's going to send a response to this node, then it's going to take that response and give it as it's a feedback. So it's like promise. I'm going to give a promise. So whenever the next, the other node gives me the response back, I'll fulfill the promise by giving the response. So threads and this kernel space. So they included one more thing. What happens is, as soon as read something from a database, so you get the data, but what happens is immediately you won't get the data. So there is a thing called kernel space. So data flows from user space to kernel space, and kernel space will send you the data to you. So they avoided the kernel space, because kernel space is managed by the kernel, which again uses threads. So this is now called page cache, so which is again the same thing. Whenever you request for a page from the database, you go to page cache and then you will get from the page cache. So they avoided page cache also. So this is structure. They avoided the page cache and they went for the row cache. So what is the data model? Scilla doesn't have any new data model. It followed the data model of the Cassandra. So what's the data model in Cassandra? Cassandra, the thing is, so forget about optimization. Build your tables in such a way that it improves the performance on a query basis. It's more like query driven process. It's not like if you have data, you optimize it, you normalize it, everything. Go with the flow, go with the query, and optimize according to the query. So that's the thing. It follows this ring shape. Instead of one centralized, Cassandra has a ring shape, so that there is no failure. Even if one node fails, other node will process the request. So what are the goals we have now? So Cassandra, what does it follow is spread data around the cluster. That's the one rule, and minimize the partitions. So we'll go for how the partitions looks. So for example, here you have three guys. One guy name is Pike County, Lee County, and Line County. So when we request one username, so these three names are distributed on each and every partition. So one partition has data related to that particular user, and this one has another user, and that one has another user. So when you see the query here, there are two ways to write queries in Cassandra, create tables in Cassandra. So For example, I created one table which has partitions based on username and the other table which has partitions based on email. So suppose if I want to...
That's it? Thank you. The next, the Neo4j by the manager. Matthew.
So my tutorial is Neo4j, which is the hit of graph database. Neo4j, the word itself says Neo4j. The J stands for Java here, and it's was leading open source graph database. It's written in Java. So what exactly is a graph database? A graph database is genetic data. It's got a lot of nodes. The nodes, they are associated via relationships. So Neo4j use cases. The first one is the real-time recommendations. So we can see that social networks, they are highly in need of real-time activities. So here real-time recommendations are used. The next one is master data management. Again, to get a 360 view of your customer activity, this one is used. There are different queries for each of them. Fraud detection. In order to avoid the fraudsters to come and leave a lasting fraud imprint, there are again queries used for this. Graph-based search, similarly network and IT operations. The property graph data model, so for example, AdLoveStan.
So if your database is selected, what kind of data set are you thinking to store in your Neo4j database?
First of all, it's a graph one.
Yes, so graph among the graph data structure. For example, what kind of data are you thinking? So did you search any data set?
Not really.
Yeah, that's also one thing to practice, because we didn't have many chances to use such a graph data structure. Okay, so that's you
The
can
common
search
use
it.
cases, I think something related to like social media.
Yes, that's what I'm suggesting.
Yeah,
So you need to think about that,
and
and you can mostly focus on the like a function to select whether to query, such as from the graph database, rather than the performance or other things, because it's different from the other data set, but it's practically used a lot also. Okay. Okay, thank you. So next one, Oracle NoSQL database by the Patel. Patel, not here today? Okay.
Hi everyone, my topic is Oracle NoSQL database. Oracle NoSQL database is, of course, Oracle provided distributed database which will have the data types as key value chains, and yes, it provides transactional semantics for data manipulation operations, horizontal scalability, easy governance and monitoring. That means the developer doesn't have to be worried about what if the load is increased after he develops the application, or about the database management or the monitoring or maintenance of the database. And some other characteristics are like architecture. The architecture is based on Oracle's Berkeley database, which is a highly available database, and other characteristics will be...
Oracle NoSQL database is a different product, or is a part of the existing Oracle IDBMS?
It's a different project.
It's a different product. So it's not the part of the existing Oracle IDBMS?
No, it's not.
Okay.
It has
other characteristics like highly available, its fragmentation, support and fault tolerance, load balancing, ASIC properties. JSON support also has integration support for Apache, Oracle, MySQL, and Hive. This is
It's also working with existing relational database or not? So for example, I have the IDBMS here for the operational system. Then I'd like to have the NoSQL database for example, document. Are they working together or is not much relevant?
It has support for some of them like Oracle Big Data, then Apache Hadoop. And I'm not sure it has integration with every database or not, but mainly it has with Hadoop and Oracle Big Data.
Okay, go ahead.
And this is how it shows like in different scenarios we can obtain either the fastest or the most consistent way or either the most durable, depends on our need. Then this is the application, how, it's request processing, how the request processing is done in database. What happens is application will be providing request to Oracle NoSQL database. This database will firstly assign a key, and then it will map the key referring to the tables named SSDs and partition tables, and it will assign the value to that key, and that's how the value will be stored. And it also has a replicas, so that if there is something wrong happens, we can have the backup. And these are some of the current applications.
Okay, thank you. And next, the Venkata for the data stack.
So I've selected data stacks as my university DB. So I just want to discuss a brief introduction about Cassandra. Cassandra was initially developed at Facebook in order to handle their large data from multiple servers, and then it was released as an open source by Facebook in the year 2008. By 2009-10, there were a lot of developments from the open source to Cassandra, and then DataStax was started by two people, Jonathan and Matt. So then when they started to develop something regarding the Cassandra, they initially started thinking whether Cassandra could solve all the real-time solutions or real-time problems or not. So then the first 3 years they took to develop an internal mechanism and to check whether it could solve all the real-time solutions or not. And then they have developed the base. The DSC base is completely on Apache Cassandra. And in fact, the DataStax have provided most of the existing Apache Cassandra to whatever features Cassandra now has. It was the part of it has been developed by DataStax. And then since 2016, there's a lot of change and there's a huge evolution in DataStax. They have emerged as one of the leading NoSQL DB providers. So now coming, since it is developed on Cassandra, the main objective is always on. According to the current technological trends, whatever happens, the availability should be the highest criteria. So it is built on the same concept. It is always available and is effortlessly scalable. So it is scalable to any kind of application, whether it's built on Java, C#, Python, or whatsoever application. It is developed on any language. It is scalable. And why DataStax? Although Apache Cassandra, it provides most of the features, what DataStax distinguishes from Apache Cassandra. So
is it based on the Cassandra or is it to compete with the Cassandra they developed?
It is based on Cassandra. Initially it was based on Cassandra, but after that, since 2016, there has been a lot of changes in DataStax. They have completely evolved as a big company.
Is it the same company or is it a different company?
It's a different company. Now it's completely different company.
Yeah, okay.
Now it's completely different company. And from the year 2016, they have been releasing different versions. Like the 3.1, it came with the SQL, the Cassandra query language, and 4.1 came along with a huge security system with the databases, and then the 5.1 came with OOP Center. OOP Center, it is useful for deploying any kind of application to data stacks. And recently, the 6.1 version, it comes along with a cloud support system, and it's a unified data platform, which means that for Apache Cassandra, for the search we use Cassandra, and for analytics we use Apache Spark. So, but this is an application which is built, whereas you can search for the data, you can analyze the things, you can do the analytical part, everything can be done in the single database. So this is one advantage with this. And Apache Cassandra is open source, so if there is any major fault or if there is any major doubt for the client, it takes some time to solve. But here they have 24-hour customer support, and they give trainings if they have any doubts. And so, and now the new data stacks, it comes with all these features. DSC graph, it is a tiered storage since it's built on Apache Cassandra, so it's a masterless database, and it's always available. It is 2 times faster than faster than the Cassandra, and the operational analytical operations are faster than Apache Spark.
Okay, so that's it. So last one is IBM Informix by the Shiba. Yes. So do you have? So I didn't turn on the laptop, the connection, so it's only for the.
Topic is about IBM Informix. IBM Informix is a traditional SQL DBMS. It used to be a traditional SQL DBMS, but later on it evolved into a relational object DBMS. So, but it's for at the present time, it's not just a traditional SQL DBMS, but it's a not only SQL DBMS. And that statement suggests that it supports NoSQL qualities in it as well. So the motivations why it supports that. The first thing is that the creators, the IBM developers, they wanted the database management system to support in a way that it supports the application-based database system. So the traditional SQL systems are in a way that the database structure defines how the program has to be. So that's the traditional way how SQL databases work, and they used to define how the software, the application program has to be. But with the advent of NoSQL, they wanted to do it the other way. They wanted the application programs to drive how the database should be. So that was the main motivation behind this. So Informatics, the Informatics developers, they try to add that new facility into IBM Informatics.
So is the NoSQL IBM the Informatics is a new product or they enhance the existing relational database, adapting the NoSQL feature?
It's a new model.
It's a new model. So they have also the relational database, the conventional relational database Informatics. But this is the different. What's the exact name of this product? Like the Oracle NoSQL database, what's the name of this product?
Informatics.
But the Informatics, traditionally we have the conventional relational database. That's the Informatics. So do they throw away the existing
No, they didn't throw the entire thing away. They just added a new facility to it.
So that means they keep the relational model, the engine, then they adapt the feature of a NoSQL database. Okay.
They implemented that new feature in the way by using MongoDB client. What they did additionally is that they implemented JSON listener, which enables them to, no, first of all, they didn't do that. They actually enhanced the system to actually interpret JSON format files. That's the first thing that they did. And after they did that, they wanted all the JSON format documents to be handled by a system which is completely dependent on JSON format documents, which is, and the best example for that is MongoDB client. So it gives every data in the form of JSON format. The specific characteristics of IBM Informatics in the process of supporting NoSQL databases is consistent low latency under high loads. If there are a lot of concurrent users at a particular time, it can manage to be consistent with low latency, with low lag. It's schema flexibility. And this is the specific feature that NoSQL databases actually allow the developers to have. It's schema flexibility. You don't have to have, the database that the programmers wanted is not rigid, it's flexible. They can write their own databases however they want it. It's not like the constraints of the database have to be satisfied when you're writing the application program. And it ensures continuous availability. So if you consider the CAP theorem, it's gonna choose A and B. So, but later on, just like Cassandra, it gives you 100% availability at the beginning, and later on, it's going to give you eventual consistency. And it supports dynamic elasticity in the format of horizontal scalability. And horizontal scalability is nothing but increasing the computational capacity of the system by adding extra machines, extra computer systems. And in this specific feature it's implemented by sharding data. And sharding is nothing but adding more data storage systems so that the data can be distributed among them. Yeah, there's reduced need for database administration and maintenance in this IBM Informatics. Jason,
okay, so thank you. So we had 19 presentation. So with your help, we can finish the not exactly on time, but pretty much. I think that we managed the time. So from your 19 selected the database. So I already selected the 10 databases. So based on the submission of writing up, and I reviewed the presentation before I came here, and also the live presentation today, I selected 10 of them. That doesn't mean these 10 are the top 10, okay? You don't have to worry about too much because I need to balance what I need to select some interesting database, even though your writing up is not very good, but some of the database are selected. So, but anyway, so I selected the 10 databases. I'd like to finalize the group before the class ends. So why don't you check the Canvas, so you can see the 10 lists of them. I already posted. So please let me know the other whose database is not selected can join one of the team selected the database. Okay, I'm not going to form a team. Instead, if you let me know if you work together with the others, please let me know. Then it's a first come first serve with the permission of those who are already selected. So why don't you let me know during the break time or after today's class? I'd like to finalize the team. One team probably by alone, the other 9 team will be by the 2 group. Then in the second phase, what you guys need to do is for the selected 10 database or for the selected database, you are going to implement. So pretty much sometimes I gave the suggestion or command for your implementation later. To think about one thing is the data. You need to find the data that fits to your selected database. If you are building the graph database, you need to find the graph-based data set. Okay? So otherwise, you need to make manually all of these data sets. So if think about also the characteristic of your database, whether this one is focused on something performance, or some flexible schema, or what is the main feature of your database. Then implement. You can model the data set that fit to your selected database. So you need to design. Today that we are going to talk about what is the data model and the modeling for the NoSQL database. So you can get the idea today. Then the database and the model, then you need to implement the database as well as the instance. You need to create. Before that, you need to install. Sometimes you are going to be very hard. You will be very hard to implement because those databases are not. Some of them are popular, the others are not. Even though they claim it's popular, but it's not that popular. So no other references. So you will be struggling to implement. So you need to install and implement your database based on your data set and the model. Then another thing you need to do is application. So you need to implement the application. You can think about the web application. Also, you need to consider the characteristic of your NoSQL database. For example, one of them is a Memcache database. Memcache database definitely helps with the web application. So you need to implement the web application server. Then sometimes you can focus on the performance, or sometimes you can focus on so think about to show the characteristic of your selected database, what will be the proper application. It can be web application, it can be standalone, sometimes it can be the performance. In that case, you can implement the MapReduce programming or the other big data query to see the performance of your selected database. You can use your own laptop, or sometimes you need to use the multiple server to demonstrate the master or the cluster node. At the time, you can use the GCP or the computer in the lab. So think about how to implement your system for the rest part of your semester. It will be more fun, but it's a little bit harder than the research only. Okay, so I consider also which database can be doable, which one is not easy. So I also consider such a thing. So please think about your team. So if you cannot find the property, I'm going to assign after the class this evening. Then you guys can start the page 3 and page 4. Okay. Any question regarding to the page 1 and page 2 that you did so far? One more time, these 10 selected database not based on the score. Okay, I'm going to post the score, but I consider several things. So, okay. So, yes, I'm going to post on that. Okay, so we will have the 10-minute break, then we will have the lecture for the data model. Great, why don't you first, and then we can return to the